Chapter 4.4, we're doing example 4, factoring polynomials in quadratic form. So we need to see if we can factor out a common monomial first, so always look to see if there is a GCF. In this case, there is not a GCF. There's nothing that we can divide out of both terms. So what we can look at is, we notice that, or if you take a look at it and think about, can I take the square root of the front and square root the back? Now, the reason why I think that, or why that goes through my head, is I have two terms and they're both, and it's minus in the middle. And so if I can square root the front, so square root of 16 and x to the fourth, well, that's 4x squared. Square root of 81, that's 9. So we can use a difference of two squares pattern. So there's nothing we can factor out. So the square root of 16, so remember we can do this, square root of 16 is 4, and then square root of x to the fourth is x squared. So 4x squared and 4x squared, and then just think about it. 4 times 4 is 16, x squared times x squared is x to the fourth. Then square root of 81, that is 9, so we put 9 here, and then we'll put opposite signs, so negative and a positive. So then I look even further. Can I factor this even more? So this one on the right, no, I cannot factor that because that'll get imaginary numbers. So we leave that as it is. But here, difference. So there's a negative in the center, and I can square root the front and square root the back again because the square root of 4 is 2. So let's do that. We can go further here. So square root of 4x squared is 2x. So we write that. The square root of 9 is 3. And then it's a negative, so we just do the plus and minus. And then we bring down this 4x squared plus 9 at the bottom. 4x squared plus 9. So now this is completely factored. So let's try another example on the right. Factor a common monomial if possible. So we can divide out a 3p squared. So let's factor the 3p squared, take out the GCF. So 3p squared, we're left with, so 8, p to the 8 over p to the 2, that's p to the 6, plus 3 goes into 15 5 times, and that's p to the third, plus 3 goes into 18, 6, and the p squared cancels out. So this is factorable. We're going to factor the trinomial. One way to think about that is just think about this as a squared and as a first power. So notice with these, in this form, that this value here, the exponent here, is double this exponent here, right? 6 is 2 times more than 3. So what we can do with that 6, is we can split that. So we have 3p squared. P to the 6, we could make that p to the third and p to the third. So split it in half. Because p to the third times p to the third, you add the exponents, you would get p to the 6 back. So let's factor this like normal after that. So it's just splitting it up first, and this should match the exponent of the center term. Okay, so that should match. So then we could do the x method to finish out what goes on the right side. So it multiplies to 6, it adds to 5. 2 times 3 is 6, and 2 plus 3 is 5. And they're both positive, so it doesn't matter where it goes, so it goes right in here. And this is completely factored. Now it looks a little different. So it has a 6 and a 3. Now let's multiply it back through just so you can see that this is true. So we should get this back. I'm going to multiply here. P cubed times p cubed. That is, so you add the exponents, so that is p to the 6. Then we have the outside, 3 times p to the third. That's that. Then we have 2 times p cubed, so that's 2p cubed. And then we have the last, which is 2 times 3 is a positive 6. So notice, these are like terms. So this becomes p to the 6, we bring it down, 3p cubed plus 2p cubed. We just add it together. That becomes 5p cubed plus 6. So notice we get back what we had in the beginning, and then we have the 3p squared. And then if you multiply this back through, you would get this one all the way at the beginning. So that's a way to double check. So I'm just showing you that this works. Now let me do a couple more examples on that. So p to the 6 and p to the third. It works for other patterns too. So this first exponent needs to be double. So if I had, for example, x to the 10th, then this center term needs to have an x to the 5th power. We could have x to the 12th power. Then this has to be x to the 6th power. Okay, and so let's see, let's do an example. So we'll do this one where this is a -3. And so this would factor, you would split it up. This goes x to the 5th, so cut that in half. And so you cut the 10 in half, and it should match this number in the center, the 5, the exponent of 5. Then if we were to factor it -3 to get +1, that is a +3. Actually, that was where it has to be a 2. And then a -1. 3 minus 1 is +2. And so that's how that would work. Okay, now let's do the same thing with this 12th power. So you cut the 12, the exponent in half, it's 6. And then notice again that it matches this 6 up here. Then you factor it +3 and -1, and so that is how that factors. Okay, you could do the same thing with the 4th power, if this was to the 4th power, to the 8th power, and so forth. So go ahead and try these examples down here. For number 8, just to kind of give you a hint, it's -16 n to the 4th. I would, let's factor out a -1 for that. So work with this in this way instead, 16 n to the 4th minus 625. Okay, if you try this out, so number 8, you could square at the front, square at the back. Square root of 16 n to the 4th is 4n squared, so 4n squared and 4n squared. Square root of 625 is 25 times 25, so +25 and -25. Then the one with the negative, I can square with the front and square at the back again, so a difference of 2 squares. So this one I factored. Square root of 4n squared is 2n, and then 2n. Square root of 25 is 5 and 5, and then opposite signs. And you just bring down the rest to the front. For letter A, square root of 625x to the 8th, that's 25x to the 4th, and so I split it up. Square root of 256 is 16, so the front is 16, the back is 16, and then negative and positive. Then this front one, because of the negative, we can square root again. The square root of 25 is 5x squared, and the square root of 16 is 4, or square root of 25x to the 4th, is 5x squared. And then, so this is completely factored. 5x squared minus 4 times 5x squared plus 4 times 25x to the 4th plus 16. For letter B, you can divide out a 2x to the 5th from every term, so you put it in the front. You're left with x to the 8th plus 5x to the 4th plus 4. So 8, we can cut that in half to 4, right? So that works out. If this is double this, then we can split it up. So x to the 8th, we change it to x to the 4th and x to the 4th. We can do the x method, so it multiplies to 4, that adds to 5, and that's 1 and 4. Then you split it up. So 2x to the 5th times x to the 4th plus 1, and x to the 4th plus 4. Number 9, the last one, you can divide by 5w squared by each term, so it goes in the front. You're left with w to the 4th minus 5w squared plus 6. So it multiplies to +6, it adds to -5. That's -2 and -3. So it's 5w squared times w squared minus 3 times w squared minus 2.